that last week we attempted to make this unconventional walking feet contraption here. So you remember we were doing this little combat robot series. Why? Because I want to make one, and I'm gonna make you all suffer with me. And you get a weight bonus if you use what they call unconventional locomotion. So normally it's a 3-pound robot, but you can make your robot weigh more than that if it doesn't have wheels, if it uses some other way to get around other than wheels. And this is one of the ways that I found that is not wheels. So
tracks count, or is that?
I think tracks count as wheels. Yeah. That's good. That's a good question, though. We should look that up. But so we attempted to draw this last week, and we kind of failed. We made a drawing, but we kind of failed-ish. And now I'm thoroughly prepared and understand the relationships between all these joints and slots and pins. So we're gonna start from the beginning, so everybody can understand these joints and relationships. And hopefully we'll actually make some joints today. So we do have a new person. Welcome. Hello, hello. So don't hesitate to pipe up if you need a hand.
I'm lost already, so.
And it's totally okay to like sit and take it in, and like ask questions as you see fit. If you don't feel like keeping up, nobody's gonna make you. This is not This is not gonna be on the test, because there is no test. All right. So I'm gonna start a new document. And on this new document, I am going to start by creating a sketch. So in general, everything we do in Fusion 360, we start by creating a sketch. From our Create menu, we'll click on Create.
Okay, create a sketch is that one right there before create and drop down. Create a sketch. The create drop down right there.
Oh, okay. All right, okay.
Cool.
Okay.
All right. And then we'll create a sketch. One of the beautiful things about Fusion 360 is there's lots of tooltips. So if we just stop moving our mouse, it will tell us what it wants us to do. And what it really wants us to do is turn out half of these lights, so it's easy if we actually see the screen. So the statement there is really saying it wants us to pick a plane or a planar face. So a plane are these three surfaces that we have going on here right in front of our eyes. These are kind of like imaginary walls and floors in our three-dimensional room. And I'm just going to go ahead and pick on one of them. I'm going to pick the one between my blue and my green axis. That happens to be the right or the left side. And we'll just click on it there. And now we are creating a sketch. We're editing a sketch. So we've got all of our sketch tools across the top. All of our sketch tools up here. And normally what we would do is we would grab from our Create menu and we would start drawing stuff. But because this is kind of the advanced or intermediate class here, we're going to start a little bit different way. I want to start our drawing here in the Modify menu by adding some parameters. So we're going to add some custom user parameters that we're going to utilize as we start our sketch. So in the Modify menu, we'll come down to Change Parameters. And now I've got my Change Parameters window here. We want to add some user parameters. And the Add New User Parameters, the little button is right up here. It's a little plus button. And in theory, if I hover over it, it would tell me what it is, but it did not.
Just let you ask questions if you have
Are we moving in the right direction?
Yeah,
Cool.
I just don't, don't know the menu on this.
Sure.
Yeah, we'll try, and then if I
Okay.
need help, I definitely
All
will
right,
come.
sorry,
No, don't be sorry, I appreciate it.
Mike could be teaching this class. So,
No.
He's the
All
one
right.
that told me about the class.
okay.
I can teach the basic stuff.
So, we're going to name this user parameter. So this is going to be our pin size. Importantly, you cannot put spaces in a name. So I'll do like a capitalization thing, or you can put an underscore in there, whatever makes it easier for you to read. We'll leave the units as inches. That'll be fine. We'll roll with that. And then the expression here, this is where we're typing in what our pin size is going to be. And our pin size, let's make it 1/4 of an inch. So 0.25 inches. And then of course we can have a comment here. This is kind of nice. If you're not sure if future you is going to think that past you was stupid and why did I name it pin size, I can say this is the size of the pins. And then if I say OK, it created that user parameter. So what's the purpose of this? The reason we're doing this is because I want to make a design that is easy to change and alter the sizes of at will, because I don't know how big I'm going to want to make this thing. So, and by adding user parameters, instead of calling out 20.25 inches like 6 times in our drawing, we can just write it once, and if we need to change our pin size, we only have to change it once instead of changing it in the 6 different places we use this. All right, let's make another user parameter. This is going to be our travel. Just travel, I think is fine. It's going to be the distance that the foot moves up and down. And our travel, let's also make that in inches. And let's also make it 1/4 of an inch. Let's make it 1/2 of an inch. Let's see how that goes. And then it is the travel distance of the foot. It's the travel distance of the foot vertically. We'll see if I spelled any of those words right. Probably not. This is not a spelling class, though. This is a CAD class. All right, and
You misspelled 2 of them. But that's okay.
Okay, good. Thank you. Well, we'll correct them later, maybe. Or future me will correct them. All right. Do we want to add one more parameter? Let's not. I think this will be fine for now. Yeah, and then I'm going to say OK. All right, so let's begin by creating a circle. So from our create menu, let's go ahead and grab our, from the circle menu, a center diameter circle. And I'm going to make this center diameter circle right on the origin here, right in the middle of my world. It's, without getting into the weeds too much, it's a good rule to have something on your sketch when you're starting from the beginning connected to your origin, so you can constrain things in space as well as in size. And the only way we have to constrain things in space, spatially, is by connecting it to the origin when we have nothing. So I'm going to click and place the center point of my circle, and then I'm going to move my mouse out, so it's a click and move, not a click and drag. So I clicked, I released, and then I moved, and now we can use one of those user parameters that we typed in. This is a pin, And if I just start typing PI, it'll say, hey, you mean you're trying to type that user parameter pin size? You better believe I am. And then you just hit enter. And it will place that user parameter for us. All right, let's place another circle. So from our create menu, we'll come down to the circle option. We'll grab that center diameter circle. And I'm going to purposefully place this in the wrong spot. So I want it to exist right underneath my first circle. But I'm going to bring it into line using some constraints here after the fact. So I'm just going to go ahead and place my circle off to the side. Again, this is going to be our pin size. The diameter is going to be the pin size. And I'm going to hit enter and place that measurement. All right. All right. So now our first circle is fully constrained. You can see it's black. The lines that make it up are black. And if we clicked and dragged on it, we cannot move it anywhere because it is locked in position in space and in size here, whereas this other circle, I can just freely click and drag on it and move it wherever I want. Let's solve that problem. So from our constraints menu, if I choose the horizontal vertical option, and I choose the center point of my top circle and the center point of my bottom circle, then they will pop into position. And now if I click and drag, I can only move it up or down. It won't let me move it left or right. Now to finish constraining that, what we want to do is we want to define a distance between these two center points. And we can do that in the create menu here. We can choose a sketch dimension. It's also the D key on your keyboard. So we can define a distance between those two circles there. And once I define this distance, I'll come around and take a look and see how you're doing. So to define the distance, I click on the center point of one circle, and then I click on the center point of the other circle, and then I've got this measurement that I can place in there. And this measurement is going to be our travel. That is our travel right there. Alright. Getting them locked in. Moving in the right direction. How we doing?
No, I swear.
That's alright, don't worry.
I think I Z, but I think I did too much. I think I erased the name and all that.
You can use that over again too, that whole arrow there. Yeah.
Oh.
There you go, there's a circle. And then, so if we forget to add a dimension, like it doesn't look like that circle has a dimension.
Okay.
So from our create menu, we can click on the sketch dimension option, and then you can just click on the circle, click on the edge of the circle. There we go, and then move your mouse to the outside, and then you can click and place that measurement. So you just click anywhere and place that measurement. Now you can change it to whatever you want it to be.
Oh, there, okay, now it's popping up there, okay.
There we go, and then you just hit enter. There we go, and then try doing that one more time. Place
Okay,
another circle,
in a
try to
different
make
spot.
it like underneath it-ish.
Okay, got it, thank you.
Cool. Yeah. All right, so.
Oh, there's a function.
All right, so for those of you at this next step here, what we want to do, this is going to be the slot part of our mechanism here. So there's two ways that we can make a tangent line, and I'm going to show you both of them. So if I click, you can see I can that's that little icon there, that little blue circle with a blue line alongside of it. That is my tangent constraint here. And it's fairly easy to get it on the second circle, but then it kind of disappears on this first circle. So what we can do is we can draw a line that connects both of those circles, and we can get our tangent constraint to pop up pretty easily down there. And then to add our tangent constraint, we can add it after the fact from our constraints menu. Errors over constrained. Oh, so it won't let me add a tangent constraint up there. Does anybody know why? So I've got a horizontal vertical constraint here and a tangent constraint here, and these circles are already directly underneath each other. So if this line is straight vertical and these circles are the same size and directly underneath each other, this is automatically tangent. In fact, I bet if I take this horizontal vertical constraint, if I delete it, I bet it'll let me add my tangent constraint now. Sure will. So either a horizontal, vertical, and a tangent, or two tangents will do the trick. I was going to show you the pro way that I like to make a two tangent line is if you hold down the shift key before you start placing your line. And now I click on that circle, you can see while I'm holding the shift key, it kind of forces that tangency on that circle. And now it's easy for me to get a tangent to both of them at the same time if I'm holding down my shift key. So we want to connect up our two circles with a couple of tangent lines. There we go. So now this is the fun part, maybe? Rules. Rules are fun. So all of the kind of rules about your sketch are in this constraints menu.
Okay.
So we want to add a rule that says, hey, this circle has to be directly underneath this circle.
Okay.
And that in the constraints menu, that rule is called horizontal vertical. So if we choose the center point of that circle, and we choose the center point of the other circle, there we go. And they're straight. Yeah. And now, so we dimensioned our circle. Remember we added a dimension for our circle?
No,
Oh, that's all right, yeah.
I don't want to
So-
just, I
No
can
worries.
just watch.
Oh, I don't want to, yeah, that's
No,
totally cool.
I don't want to disturb anybody else from
Not at all, not at all.
How did you zoom in? Was there a
I used, so there are some tools at the bottom that you can use to zoom. Down here, there are some plus and minus icons. On my trackpad, if I push in with two fingers, if I use two fingers on a trackpad, it zooms in and zooms out for me.
How about when I move it, it's
Also like pinching, you can also like pinch to zoom in and zoom out.
two fingers?
No, yeah, I can do it.
All right, cool.
You can seal the mouse and use the wheel on the mouse too.
It's like a scroll.
So now let's make the rotational axis here. Let's go ahead and from our create menu, let's grab the circle tool again. Circle, center diameter circle. We're going to use those same tricks that we just learned. So I'm going to place my circle just kind of somewhere off to the side here. This circle has to be, it has to be our travel. Has to be the distance that it travels plus our pin size times 2. I'm going to plus the pin size twice. So plus pin size, and then we need just like a little bit extra. So let's also just add 1/4 of an inch. I think that will be phenomenally adequate. All right. So is our travel distance plus the pin size plus the pin size, so pin size twice. So because our pin is going to be here, and it's got to be able to travel the same distance that travels here. So kind of this slot is kind of like duplicated in here, except without the slot. I think we probably could draw it like that, actually. It's fine. Actually, hold on. I'm going to call an audible, because I think let's try something different. I bet if we go and grab a rectangular pattern option, maybe this is just creating extra drawings here for no reason. If I create a rectangular pattern that is all the two circles and the two lines. So the rectangular pattern option, sorry, it was in the create menu and then down to rectangular pattern. A rectangular pattern is also a linear pattern. I think this is my favorite way of drawing this that I've done so far. And I'll tell you why, because this spacing now is going to be down in our timeline. It's going to be a thing that we can change later, which is great. So let's set the spacing to be negative 2.5. For me, it's a negative number. For you, it might be a positive number. But I want it to go down 2.5. And then I don't know if this is necessary or not. When I'm making a rectangular pattern, you know, there's always an option for an X and a Y. Like I can make a pattern off to the side here. This quantity is set to 3, even though the distance is set to 0. Again, I don't know if this is necessary, but my OCD brain makes me turn this down to a quantity of 1. So I don't know if it's making sketches that are overlapping on top of each other or what the deal is. All right, so now this is pretty cool. So now let's go ahead and grab from our create menu.
Boss?
Yeah.
Okay. I had to backtrack and destroy my circle. What was your spacing or what was your setup?
Oh yeah, good question. I believe I was set to a spacing type that is extent. Yeah. So my spacing type is extent, and then my distance is negative 2.5.
Thank you.
Yeah. This is one of those distances that is highly variable, though, I think. Maybe not. We'll find out. This is part of the joy of doing stuff new. Is like, I'm pretty sure I understand how this relationship works, but then I come across something that makes me question it. All right, so now I'm gonna come to my create menu. I'm gonna draw a couple of lines. So I'm gonna draw a line that goes from the end point of one circle down to the end point of this other circle. And then I'm going to do the same thing down here. So I'm going to draw a line from the end point of from the center point of that circle to the center point of that circle. And the only reason I drew these lines is I want a center point, the center on the slot. And if I draw some lines there, I can have a center point constraint that just kind of pops up really easily. So I'm going to turn those lines into construction lines, because the only reason I need them is for locating a center point. And to turn something into a construction line, totally not really necessary, but I think it just kind of cleans things up a little bit. Something that's nice about the difference between a line and a construction line is a line will divide up a sketch into two halves. So I can only click on one half of this bottom at a time, whereas a construction line does not divide these things here. All right. So, oh, I accidentally clicked finish sketch and I did not mean to. Now, oh yeah, go ahead, Nick.
Putting a line on the top slot?
I'm not. Yeah, just the middle and the bottom. And now that I've got that line in the middle and bottom, now I can place a circle at in the middle one, right at the center point of that line. And I know I get right to the center point because I get that little blue triangle. The little blue triangle is my midpoint constraint that's kind of popping up there and saying, hey, we're going to add that midpoint constraint if you click right there. And I do indeed want to add that midpoint constraint. And now we don't have the guesswork here that we had before. So this is going to be our offset cam pin, and this whole thing is going to rotate around that. I'm going to make it 1 inch. That seems like a perfect size. Now I will say that if we want to keep this fully parametric, even though we could see that this is 1 inch is a good size, maybe the better way to do this would be to make this circle, instead of with 1 inch, by saying, we should say, hey, the same way we were going to make it before. It's our travel, it's almost the travel times 2. But if we just make it our travel plus our pin size, where does that get me? Yeah. So travel plus the pin size.
Plus pin size.
Plus pin size. Yeah. That's really nice. And the beauty of doing this is, like, it's the pin size and the travel that I know are going to be the variables that I'm going to want to change later. Maybe I want to take a bigger step, or I'm going to want to change the height here. So if we keep everything based on those two parameters, then it's real easy to change those things later. All right, and then the last thing down at the bottom is that weird ellipse. So let's grab our ellipse tool, and we're going to place our ellipse also at the center point of this line here. And our ellipse is going to be the same height as these pins here. So the ellipse tool is kind of funny. I don't really like the way this ellipse tool works, but the ellipse tool is going to be our travel plus 1 pin, because this is our travel right here, and there's a half a pin on each side. So it's going to be our travel plus our pin size. And that's going to be the height of our ellipse. And I can click and place that measurement. Now the width of our ellipse here is going to be our travel plus our pin size twice, I want to say. Plus the pin size plus the pin size. And
what's that formula
yeah,
there?
that looks right.
So you got
So it's the travel plus the
Okay.
pins
for
over.
up like this. What was
The spacing here, the extent of this is 2.5 inches.
that? No, I mean for the ellipse.
For the ellipse, so the ellipse, the height of our ellipse is our travel plus our pin size,
Travel plus.
and then the width is the travel plus the pin size twice. And it's just a coincidence that it's roughly the same size as this circle. You know, we've got a little bit more extra on the outside than we really need there, but you know, that's fine. All right. Take a walk around, see how we're doing. Pretty good, pretty good. It's all right, that's all right.
This is way, way too much over my.
Sorry, yeah.
That's okay, I'm still learning stuff, so that's fine.
How you doing?
I'm somehow unable to make an ellipse.
yeah, right, yeah,
Okay, so ellipse,
Yeah.
we put that there, put the center point there.
Yeah, and you can go that way first. So we
Okay.
can type in, so that's going to be the travel plus pin plus pin. And then don't click enter after you click your pin size.
Oh, that might be.
You
what I
actually
did
have to
wrong.
place that. There we go. So there you go. Now if you click there,
Ah,
now you
okay.
can. Yeah.
Gotcha.
Yeah, it's the ellipse tool is weird. A lot of times you get used to typing in your measurement and then you're like, all right, enter.
Yeah.
But that's not how the ellipse tool works. It's unusual from the other tools. Here, my drawing is a mess. I should clean that up a little bit. There we go. All right, cool. So now we can place all the outside lines here to kind of draw the outside of this frame here that we're going to try to make. Just as a reminder, this is the basic shape that we're going for here. When we get down to this curve, we'll be specific about the radius of this curve. But other than that, you can make your outside shape however you'd like to see it. Another thing that we want to be conscious of is this distance right here has to be greater than this distance. Just because if you're going to make it a double-sided walking foot thing, eventually I want to make this double-sided so you can have a foot on each side. And if this distance isn't thicker than this distance, then this touches the ground at the same time this does on the opposite side, and they're moving in opposite directions when they cross, so it doesn't walk. You just be making friction against each
What
other.
about the top and the bottom of the slot? You got a little extra room?
What do you mean? Here?
Yeah.
Oh, that's a second.
When it goes up and down, you know?
Yeah.
Add a little clearance so it doesn't hit the pin.
Oh, we could probably add clearance in a lot of spaces, but we can worry about that later.
Right.
Yeah.
Right, we're drawing.
Yeah. All right. So, tell you what. Let's make our bottom curve first. Yeah, Mike, go ahead.
Does the radius on the bottom of the foot correspond to a circle diameter?
Yeah, I think that the radius of the bottom of the foot should correspond to the pin position when the foot is lowered. So when the foot is at its low position, this is the center of the pin. Is that correct? Let's verify that. Over, yeah. So when the pin is down, so this foot is at its down position. So I think the center point of the radius of this curve should be at the center point of this line because it rotates around that line. So if it rotates around that pin right there, then we can maintain connection with the ground for the full distance of that curve. Does that make sense? So we can use a tool that we don't get to use a whole lot here. We can make is it a arc? Is it a center point arc? Yeah, center point arc. This is not a tool that I find myself using on a regular basis. So if we grab this center point arc option, It says first I'm supposed to place the center point. So I'm going to place the center point at this top pin here. And now I'm defining a distance here. So, if we want this to be fully parametric, this should be some sort of multiple of our travel length, shouldn't it? We're gonna wing it for now. I'm gonna make it 3.5 inches. And now, now that I've typed that in, now to place that measurement, I have to click and place. And now I can kind of draw out my arc here. I'm not clicking and dragging, I'm just moving my mouse left and right. Oh, it gives me a degree measurement, which is kind of nice.
I thought you said bottom circle or bottom pin position was the center point of the foot radius.
No. No, it's the top circle.
Okay,
My bad, sorry.
no problem.
All right, I'm gonna make it 18 degrees. That seems like a fine number. And then I'm just gonna draw some lines. Or actually, let's go ahead. I'm gonna draw. I'm gonna do that same trick. I'm gonna do that same trick up at the top. So from my create menu, I'm gonna go ahead and grab arc, center point arc. And I'm going to make the center point of this arc the same place. I'm going to make it at this top pin. And then I'm going to make a curve that goes that direction. Yeah, 75 degrees-ish. That looks fine.
Oops.
And again, these outside lines are not as crucial. So I guess this radius might be crucial. I'm only kind of guessing on that relationship right now. So I'm just going to draw a couple of lines that connect those dots. Not really that crucial how those lines connect. You can make a fun shape if you wanted to. I encourage you to make a fun shape. Fun! That's what we're here for, right? Alright, let me come around and see how fun your shapes are. So much fun. On a scale of 1 to fun, we're having fun right now. That's what that looks like. The shapes of, oh nice, yeah, that's good.
I took a circle based on the pin here.
Yeah.
And then a circle, the radius on the bottom of the foot. I just dropped a tangent line and mirrored it based on the construction line.
Yeah, nice.
And I'll cut that away later.
Nice, nice. Yeah, and I'm gonna mirror my lines right now.
Now,
So
Are you doing a diagram? Is that what you're doing?
we're actually gonna extrude this out very shortly.
Oh.
So
Okay.
the whole reason we spend more time sketching recently. You think that's accurate? We spend a lot more time in the sketch in the last few classes than we do.
With the complicated stuff.
Yeah. Yeah.
Like he showed me the pumpkin. That's like something I want to do. All this stuff is just.
Right. Sure. This is, I guess, more like the pretengineer in me. I'm not an engineer, but I did stay at a Holiday Inn Select last night. So, so we can click Finish Sketch. And now I can extrude out a shape here. So from my Create menu, we can name a sketch. Look, I almost forgot to name a sketch. This is called the foot. It's a foot. All right, now from our create menu, I can go ahead and grab the extrude tool. And then this is the thing that we're going to extrude here. And we're going to come out a 1/4 of an inch. A 1/4 of an inch is probably a good amount. I made these out of 1/8 inch, and I may end up going that route later, but you know, 1/4 of an inch is fine for now. And then I'm going to say oakley dokley. And then let's also extrude out a couple of other shapes here. So let's extrude out our pins.
Which direction did we go?
I went towards me.
Okay.
But you can go away from you. That's fine. As long as we you know, keep it visually sane as we move forward here. I'm going to extrude out my top and bottom pins right now. So let's go ahead and name this body so I don't get this body confused. This is my foot. It's my foot body. That's a strange sentence. This is my foot body. All right. Let's go ahead and grab the extrude tool again. I'm going to grab my top pin and my bottom pin. Now, the pins are either the tops of both of our slots or the bottoms of both of our slots. So I'm going to, pick on the tops of both of our slots. Let's tell you what, we can extrude out the cam pin as well. That would totally be acceptable thing to do. And let's extrude out these pins towards me. And we only need to make one of these for now. And I'm going to extrude it out just a 1/2 of an inch, just so it's a pin. It's there. And we definitely want to make sure that these are new bodies. We don't want to accidentally join these. I don't know if it'll let us join these because they should be tangent. So there should be some touching there, but new bodies is definitely what we want. And then let's go ahead and name our bodies. So we might go 10 minutes over. Is that okay with you guys? Cool. So this is the top pin, and then I've got a bottom pin, and then this middle pin here, I'm actually going to call my cam. Because eventually that is going to be like that offset cam that rotates around there. And now for our last trick, we need the actual cam part here. So what I'm going to do here is I'm going to turn off all of my bodies except for that cam pin. So the reason being is I'm going to extrude out this shape here, and I actually want to join that shape to my cam pin, but I don't want to join it to the other bodies. I just want to join it to the cam pin. It won't let me do that in the contextual menu. No, it won't. Okay. So if I turn off the visibility on my other bodies over in my bodies folder, cool. Everybody's with me? Now we can grab our extrude tool and we can extrude out the 1/4 of an inch thick cam, and we can leave it joined because it only joins it to things that are visible. So if we turn off the little eyeballs, these are kind of like layers in a Photoshop file. You can kind of turn off these little eyeballs, and if they're not visible, it won't join them to it. And we say okay. All right, cool. Hopefully, everybody's got a little foot thing. Because in the last step, we're going to animate it. I know, right? Ruh-roh, Raggy. It's no joke that I spent a majority of the day Saturday and almost all day Sunday figuring out where I needed to put these joints. It should not have been this difficult. But it's a complicated motion. It's fun. I think the order that you make these joints matters too, so we're going to do them in a very specific order. And I'm going to verify that I remember the joints that I need to be adding here. Yeah, it's just two. Yeah. Oh. All right, so first, in order to add some joints, we need components. Right now, we have our main document component that is conveniently titled unsaved to remind me that if my computer crashes, I will lose all the work that I've done. Living on the edge, that's what I'm doing. So what we need to do is we need to turn our bodies into components, because the only way we can use we can make joints here is if we have components from which to make joints from. So from our create menu, in fact, I just noticed there is a new component. The new component option is here twice. This appears to be the same new component. So you can either click new component from the assemble menu, or you can click new component from the create menu. And we want to make a new component from bodies. So I don't know how to put my magical pointer away. We want to make a new component from bodies. Hopefully, have you guys named your bodies? Because whatever your bodies are named, your components are going to be named. So it's helpful to have your bodies named already. Otherwise, you'll have to name your components. I'm going to go ahead and pick each one of my 4 bodies in my bodies folder from which to make components from which to make components out of. And like magic, it takes those bodies and it turns them into components here. So I'm trying to work out some rules for making joints. And panic! Is it time to go? No?
Wake up and
Time.
work.
Oh, you work the 3rd shift?
Oh, it's like second, I guess.
Oh, but still.
Yeah.
Late. Okay, cool. All right. Thanks for being here early. All right. One of the first things that I'm kind of working out here is something has to be rigid. If you're going to have a joint, some part of that joint is not moving in theory, and so maybe this is a good place to start. So I'm going to click on my assemble menu, and I'm going to choose to make as-built joints. Typically that's how I make a joint, because the parts that I made are already in place. A regular joint is when you need to also move the items, like the things that you want to make in joint with each other aren't already in the spot they need to be in order to move. But we want to make as-built joints. I'm going to make this top pin. I'm going to make that a rigid with the main document component. And I think about this as being like my main document here, this is my world. So I'm going to make my top pin static in the world. And so it's going to be the second component that I click on here after my pin is going to be my main document component in my browser. And again, I think about that as like my main document component is the world. The only way that I could move that pin now is if I move the entirety of the world. And I'm going to say OK. And now I'm going to do that same operation with this bottom pin here. So from the assemble menu, I'm going to choose as built joint. I'm going to pick the bottom pin there. And then I'm going to pick my main document component over in my browser and make it rigid in the world. And say OK. Cool? Cool. All right. So the next thing that we're going to do here is the most complicated joint in my mind is where I'm going to start with next, the one that does the most complicated motion. And that's this top pin here. So this top pin moves up and down and also rotates. So if from our assemble menu, we choose an as-built joint, and the type of joint this time, oopsie, we want to avoid this before I pick anything further. I've got something selected, and I don't want to have anything selected because everything but a rigid joint, all the other joints in this list here have kind of an order that you should select things in. So before I go ahead and pick something, pick a type, I'm going to click the little checkbox. Not the little checkbox, the little X. So if you've already got something selected here, because I had something selected and then I chose as built joint. So I'm going to click on the little X button there so I have nothing selected. And now I can choose a pin slot type from our drop-down menu. A pin slot is a joint that is a pin and a slot. And order of operation matters here. So what we want to do is we want to pick on the item that does the moving first. So the thing that does the moving is going to be our whole foot. Our whole foot is going to move. So our foot component I'll click on first. And then this upper pin, I'll click on that upper pin second. And now, for my third click here, is if I hover over this pin, it gives me a little, a little widget. And it's got a little flag and some lines that are on either side of it. So that's telling me that the center of rotation and the direction of travel for that pin slot. If I just click and place it at the end of that pin, it animates. And believe it or not, that is the animation that we want to see. It's funny that it won't let me. Oh, I can only preview one motion at a time. It showed me both of the motions at the same time previously, but I can preview one joint at a time, and that is indeed what I wanted to do. It's going to rotate around like that, not that much, and it's going to slide up and down like that. Now, does anybody have a slide that's moving in a weird direction? Yeah, it'll say, when you say OK, it'll stop moving. But if you need to change the direction of your rotation or change the direction of your slide, you can do so in these drop-down menus here. So sometimes your slide will come in and it'll be doing something weird. So here, this is not the direction that we want it to move. And it's just a matter of changing our slide axis. Believe it or not, that is the correct way to do it. So, all right, I'm going to click on OK. With me so far? All right, so now let's go ahead and make our next two joints. So from our assemble menu,
So is that joint supposed to be working correctly now?
no, not yet. Yeah, so not until we get our next two joints in here. So let's go ahead and make another as-built joint. This as-built joint is going to be revolute. So that is just a rotational joint here. And the thing that's going to be rotating, maybe this one doesn't matter. I'm thinking about the thing that is rotating is the foot. So we're going to click on our foot first, and then we're going to click on our cam second, and I'm going to place that rotational point, yeah, right in the middle of this circle. There we go. So that is the correct motion for this joint, is it just rotates around the center of the circle. Not the center of our cam, but the center of the circle. Alright, and then the very last joint, from our assemble menu, we'll come down to the as-built joint option. I'm going to pick the cam. The cam in this case is the thing that is doing the moving. So
Another Revolute?
another revolute joint, and it's going to be the cam is going to rotate on the world. So the cam is going to rotate against our unsaved component again. So the cam, I'll click first. I'll click on my unsaved document component second. And then the center point, the rotational point, is going to be our little cam pin there. And now, if I say OK, in theory, I can double click that. Yep, I can double click this, and I can move that around. And if I want to, in my joints here, I could choose Revolute 5, this very last Revolute here. This is a new trick that I just learned. I can say animate joint relationships, and it will just go to town. Now it's not perfect. It's not rotating quite perfect up here. I think that, yeah, I'm not exactly sure, but it's good enough. Good enough. What are we rotating?
I think so.
Yeah,
Walking.
nice.
Are you gonna print this?
I have printed it. Yeah. So
You animate this?
I actually laser cut most of these pieces. So here, if I take that part and put it there, and there it is,
Okay. Well,
rotating around.
are you gonna 3D print it, I guess?
Well, part of it is 3D printed. This
Okay.
guy's 3D printed.
All right, so the part you're doing here is not, this is just explaining for
Yeah.
you to know how to put
That's
it together
actually
and
this
stuff.
foot
Okay,
right here.
all right.
Yeah.
I understand more now, okay.
Okay, cool.
I got the drag and drop thing, but where do we?
So in your joints folder, if you spin down your joints folder, the little triangle next to your
okay.
joints folder, and then you right click on joint 5.
Okay.
You might have to click escape or something like that in here. So this is right now.
Yes, so.
And then you
Okay.
want to animate joint
Yeah, you said you
relationships.
were
Okay,
doing
got it.
There we go.
Okay.
Yeah, sweet. You're
You
rotating.
just
Oh,
change the number.
you missed your rigid joint. You only got one rigid joint, and I think you need two.
I like to do little simple.
So the top pin and the bottom pin have to both be rigid joints. You might be able to have them out and it might just be fine. So you can, if you hit escape, it'll stop the animation. So click on that rigid joint and you can figure out which one. So you got the top one. See if you can get the bottom one. So cool, right?
idea, but what are the things we would need to know if we were to figure this all out ourselves? Just
Yeah. So yes, that is a fine question. So last week we were really struggling, and thank you for the question. So let's see if I can pull up our drawing from last week. Last week, what we did was we started. We found a website. We found a website that had this lovely picture on it. And a person who has written about his experimentation and shufflers, that's what he's calling these things, these little shuffling feet to do this kind of motion. And we cut and pasted this photo into Fusion 360. Have you ever used, the Canvas?
I think you showed it a couple times when I was sitting here. Yeah.
So here is our drawing. Is this the drawing from last week? Yeah, here's our canvas. So there it is. There's that cam shuffler. And we literally just traced over it. So we drew a circle here and we drew a slot here. We were just kind of roughly getting the positions right. And it wasn't really until I stopped and started thinking about this critically that it was like, all right, well, how does this relate to this and relate to this, right? Well, if the pin is moving up and down X amount here, this pin also has to move that same amount, right? Does that make sense? So like this distance is really here too. So when the pin is in this lower position, the spacing between where it was in its upper position and where it is in its lower position is the same spacing here. And then the same here. So the pin can only move, the foot only moves up and down that same amount every time. So that spacing has to be the same. And the oval distance here is because the pin spacing here has to account for a little bit extra pin. So when your pin is in its left position, here, if I rotate it, so the pin is in its left position at 90 degrees over, and when the pin is in its right position at the other 90-degree mark, it's this same distance, right? It's just rotated 90 degrees, right? Does that make sense? And then it's greater just because our pin down here has thickness. So it's greater by our pin thickness. So I just had to kind of stop and think about those relationships. And other than that, like we could make some pretty drastic changes to this if we wanted to. So we could change, what did we, here, this is our pattern that we made. If I right click on this, I could make it, if I make it a lot bigger, let's see what happens. If I make it 4 inches, so our that's interesting. It won't let me make it longer. Why won't it let me make it longer? Oh, because this is a specified distance here. So this is now 5, let's say. No, 4.75. Let's make it 5. So now I can make some pretty drastic changes to our drawing, and we can see what difference it makes to the motion here. I'm not sure if lengthening it or shortening it is the right way to go here to get like maximum travel here. It kind of makes sense in my head that the shorter this is. So here we're not really moving a large distance linearly when this is really long, because the distance between these pins is so great. If we switch that around,
How about if it wasn't a pattern, but like if the distance between the first two is
was-
a lot smaller
yeah,
than...
sure, it was different, and that would certainly be an experiment that would be worth doing for sure, right? Is like, does this may not need to be in the center of these two. This might be actually better if this was closer to the pivot point up here, because the closer this is to our pivot point, the greater the motion we're going to have down here, right? Does that make sense to you guys too? Like the further up these things get, the greater that angle is going to be there. Smaller motions quickly may be safer. Like you make big motions, you get like a big arm sticking out in the middle of nowhere waiting to be hit. That could be a concern for sure.
Also, I think torque would be...
Sure, yeah, right. So here, this is probably, the further away these are, it's probably easier to rotate this. There's probably some sort of gear reduction ratio that we're seeing there, right? Like the relationship between where this cam sits in relationship to here. That angle is probably similar to like
It's making it easier on your electric motor.
Right,
and
right.
also that distance of the cam lobe is making it easier on your electric motor. When you make that distance bigger, that's gonna make it harder on your motor, and then when you put that closer to make
So
your
here,
step
if I say
bigger,
finish,
that's gonna make it harder also.
what if I do something like that?
You came in on a scary price. This one is right at.
I think that's moving a lot more.
What did you change there?
Snorkel.
Well, I changed that pattern. I made that pattern,
Yes.
I went up to 4 and now I went down to 2. But I didn't change the length of this leg. Like to go back up here, maybe this is what we want to be really long.
What about?
Yeah. So I think there's lots of interesting things happening here for sure. I like all the questions and fun experiments. Hey, you made it though. You made a thing.
Yeah,
Yeah.
but that's just
Here,
following you point for point,
Yeah.
as far as figuring it out or being able to sit down and do this at home,
Yeah.
no way.
And like I said, I spent literally all weekend doing
Yeah.
this. So
About a nice, easy one for next
I have-
week.
Yeah, we're gonna make wheels next week. It's gonna be great.
2 round circles, that's what I've got.
Next week we're gonna make wheels, which is only really 1 round circle. So
Okay.
yeah.
Well, all right, so I'm ahead of the game.
You're ahead of the game. You're ahead of the game. And so next week will be a beginner class.
Good.
I try to alternate back and forth between beginning and advanced. We'll start with a little bit more overview of the environment, and I try to go a little bit slower, and there will be no joints. Yeah. Unless you're joining us from Illinois or Colorado or Michigan virtually, and then I guess there could be joints on your own time. I don't know how things work. Laws and stuff. All right, so we'll see you next week.